So let's see what we have here. So we'll go into topic 2, 2.2. All the material I got from this book. Okay, so it's much easier for you to read yourself. Okay, use your time instead of probably just listen to me. So what are the key drivers of future climate? Okay. You have seen this one. You have seen this one all the time. So what happened to the hydrocarbon? Okay, when you burn the fossil fuel, the fossil fuel, it's basically it consists of basically two main elements. Okay, carbon. So it's a hydrocarbon, right? So you have got hydrocarbon. So you burn it, basically you react it with oxygen. Okay, then what happens is you form the C react with oxygen becomes CO2. And the hydrogen react with oxygen, it's form water. That's basically it. So the main issue is not water. The main issue is this. Okay. So you can imagine that every year we burn a lot of hydrocarbon. So what happened is that the CO2 is being accumulated. So this one, emission of CO2, and then it affects a lot. You have the increased concentration of CO2 in the atmosphere, and it leads to many changes. So that is what we have learned before. And then when we project what will happen to CO2 in the future, it depends on a lot of things. Okay, the socio-economic development as well as the policy, what the government, what the global government will go through it. There are many pathways that has been proposed. Okay, so for example, countries make a commitment of what to do with their CO2 production and so on and so forth. And then you will see later on in the slide that a different path will lead to different future. Okay. We'll have the projection of the future. Okay, so one of the most important fact is that the accumulation of CO2 is correspond to the increase in global temperature. Layman means the one who is not knowledgeable. Well, it sounds like you have CO2 accumulation, then probably you'll have an increase in global temperature. Well, that's it. But for us, the engineers, the one who learn science, we understand how important the temperature on a lot of things. Most importantly on the reaction. So you'll see that you shift the equilibrium of the reaction when for example, for the endothermic reaction, it goes to the right. For the exothermic reaction, it goes to the left. It increased the rate of reaction and so on. So a lot, for example, the metabolism of the microorganism change. You will probably see, a lot. You will probably see the change on the composition of microorganism in the future. Yeah, because certain microorganism will live better at, for example, 2 degrees Celsius higher than today, for example. There are a lot. And then the more you think of it, I mean, you will have think of unlimited consequences of the accumulation of CO2 emission. Yeah. So if you look into this, okay, this graph, it's showing what will be the CO2 emission? Okay, is an anthropogenic. I mean, as a result of human activities. Okay, the baseline will be around 1950, and then the projection is until 2100. So 80, about 80 years from today. Okay, there are a lot of scenarios, and then if you look here, the key will be, because the initiative started around this year, and then what you see, you have a lot of scenarios. If you get this scenario, what will happen? If you go for this scenario, what will happen? And the two scenario will lead to actually reverse on the trend. Okay, it will rise to some point. Okay, probably until 2050. Okay, then the accumulation will start. It will start deaccumulate. Basically, at this point, for example, for the what color is this? The light blue. During this year, it will go down. Okay, the annual emission will go down, thanks to the initiative. Okay, thanks to the initiative, this initiative RPC 4.5. So United Nations have developed many different scenarios of how can we curb the accumulation of CO2. Basically, the solution is simple: by emitting less amount of CO2. So what does that mean? Is basically to consume less fossil fuel, to go for the more carbon neutral or carbon negative kind of energy. So that's what we see. So see, we have many different scenarios, and what will be the consequences? Okay, what will be the consequences if this one is concentration of, if the concentration of CO2, the baseline here, we'll go to the baseline. Okay, the baseline here. The baseline here represent if we don't do anything. Okay, if we don't do anything, so it will lead us to this concentration. Okay, to this temperature. So it will rise up to about 4 to 5 degrees C. Okay, if we don't do anything, the global temperature will rise at that. And then the total accumulation of the CO2 by this time, okay, relative to, so this one is accumulation from 1870, around Industrial Revolution, to 2100. So we'll have a total accumulation of 2,000 gigaton. Okay. Then if we go to different scenario, so we will end up with less and less less and less temperature by actually reducing the accumulation of CO2 emission. So now let's see what is projected to change in terms of the climate. Okay. First of all, the temperature, it will rise up. There will be more heat waves, and then the ocean will continue to warm and acidify. Okay. Also, the global mean sea level will also increase. This is the what is projected in terms of climate system. Okay. For temperature, it's really depend on the scenario. Okay. It can, so if we stick on this scenario, RPC 8.5, it will lead to about 4 degrees Celsius in 2100, but 4 degrees Celsius above the reference. But if you go to the strictest scenario. Strictest scenario correspond to about this. This is the ppm concentration of CO2. Okay, it will increase to about 1 to about 0.4, 0.3 to 0.4 degree increment from the temperature of 2000. This is what happened. Okay, it's really depend on how we react to the current situation. Okay, and then in terms of global mean sea level, okay, it's relative to this year. Okay, so depending on scenario again, if we go to the RCP 8.5, if you ask me what is this, I don't know. We have to look into the glossary on what is RCP 8.5. So if we stick with RCP 8.5, I mean, this is the worst case scenario. The sea level will projected to rise for about 1 meter in 2100. And whatever scenario we will go for, the sea level will continue to rise. I mean, the best case scenario is the RCP 2.6, which will end up with an increase of about 0.4 meter. So if you look into the climate, okay, this is the projection on the change in average surface temperature. Okay, and the one below is on the average precipitation. Okay, as you see, temperature increment goes highest to some northern part. I don't know why. This is northern part. It really depend on the scenario. Okay, so the RCP 2.6, you will see here around here, yeah, around here. So it's around 0.5 to 2 degrees Celsius increment. Okay, globally probably around, I think I should not color it. Okay, the global will be probably around 0.5 to, I think the highest is around here. So to 2. Okay, for the RCP 8.5, then you will have, I think this zone is around, it is 2 to very dark, 2 to 10, the extreme 10 degree Celsius. Okay, precipitation, you'll see it's correlate very well with the temperature. Precipitation means that actually in air you breathe now, we don't only have the gas. Okay, you say we'll have nitrogen, oxygen, carbon dioxide, and many other gases, and it also contains water. That's why we say humid air. Humid air is air that contains a lot of water. So if you look into the they call it humidity table. Okay, humidity table. This means that it will show you that actually when you have a high temperature of air, it can contain more water. Okay, I'll give you an illustration why this phenomenon become, it is scary. Okay, so I'll give an illustration of, you get if your temperature is high, so I'll go it up, then you will have water also high. Okay, so what does that mean? So you will, so this is the surface. Okay, can be land. This is land. Okay, plus okay, the ocean. Okay. Okay, now you'll have more water here. Okay, and then in this water, it's come with cycle. Okay, it goes up as the evaporation, and it goes down as precipitation. So basically, what happened, and then we are feeling it in Brunei as well. So it goes up. So basically, there are more water in the air. when you have more water in the air, you will have heavier rain. Okay, you will have heavier rain. The infrastructure to handle runoff the rain was developed most likely like 50 years ago, depend on the status of the country. Okay, European probably 100 years ago, Brunei probably 30, 40, 50 years ago. Okay, it's really depend the infrastructure. How big is the water canal? Okay. This is the reason why you see, for example, many European countries now also suffer from flooding. Germany, Belgium last time, because of their civil construction was not designed to anticipate what happened 100 years from that point. Okay, normally when you design a house, you calculate the last 30 years what was the heaviest rain, and then you design your water channel based on that. But now, since you take your design based on what happened in the past, and you didn't project what happened in the future, and then you then we actually suffer from that kind of approach. Yeah. So that's the damage from the rising temperature and increase in the precipitation. Okay, so what are the other consequences? It's amplify the existing risk. So basically, risk is more riskier, and then it brings new risk. And then another important thing is that the risk is not evenly distributed, and then most is felt by developed country. Okay, so most of the risk is felt by the less developed country. So if you look into the energy statistic, the one who produce most of the CO2 is the developed nation, but the one who actually suffer is the underdeveloped nations. Okay. So this slide gives summary of risk. Okay. How can we see? Okay, we look into the legend. Okay, we have three types of risk. Physical system, we have a biological system, and human managed system. Yeah. So each of these three category, it's include, for example, physical system, glaciers, snows, ice, and permafrost. What is this? I don't know. Related to river, lakes, floods, and drought, coastal erosion, blah, blah, blah. Okay, that is the thing. Biological system include terrestrial ecosystem, wildfire, marine ecosystem, and so on. And let's see, let's pick two different countries. Yeah? Okay, let's pick two different countries. So for example, Africa, mostly less developed. So they will suffer more on the compounded stress on water resources. Okay, water resources, it will reduce crop production and livelihood and food security factors and waterborne disease. Okay, this is what will be felt mostly by the African nation. Okay, if you look into which one can European will suffer most. Okay, this is just an estimate. Yeah? Increased water restriction. For example, from the physical system, it's also coastal erosion. You see here, increased damage from river and coastal flood, and increased damage from extreme heat event and wildfire. See, you can see this mapping. It's nicely done. Okay, probably the tricky part will be how they come up with the bar. I mean the number. How severe is the consequences? Let's look into what happened to us. This is Asia. We go where? Okay, this is the legend of how you interpret the bar. Asia, increased flood. We've seen it recently in Malaysia. In Indonesia, you miscount how many floods. It's happened every rainy season. Heat-related human mortality probably not happened to us. Increased drought-related water and food shortage. Okay, I don't know they come up with this graph. Okay, in terms of food production, I'm going to skip this one, but it's related to the temperature. Okay, food production related to the temperature. So it's basically how good of a climate that support the growth of the plant. That's number one. It's also to the availability of water, because agriculture consume most of the fresh water. Okay, this one, food production, you will see how actually it changed. This is the catch, yeah? I think, yeah, maximum catch potential in the ocean. So if you look, let's look around us. To, yeah, us, we are here. I think we are Southeast Asia will suffer the strongest impact in terms of catch potential. This is from fishing. If you look here, from -6 to -50% of the catch. Okay, on the fish. If this is the region of Southeast Asia, as it's very strong. The impact is very strong. This is in terms of yield production. What will be the projection? The projection is from 2010 until 2100, so it's about 100 years. What we can see, when I learned this one, I don't really get what does that mean. Some part, okay, you'll see two things. This is the increase of yield, basically the first bar. Okay, and the other side is decrease of yield. Okay, how come we get some increase, some decrease? Yeah. Okay, for example, this is because of the condition for crop is changing from is different from one place to another. So the global change of climate might increase some part of the region, farming region. It will decrease another part. So you see there will be shift on the productivity of the farm. Some will increase the yield, another will decrease the yield. But overall, as you see, until 2030, most likely we won't see an obvious change on the yield, but the drastic change will be felt from 2030 and beyond. Okay, you see the more of decrease than an increase in terms of crop yield. So next, we'll see what is the future risk and impact. By changing climate, this is the summary. It will affect human health by exacerbating health problems that already exist, increase risk for the people, asset, economy, and ecosystem. Okay, major impact on rural area, on water availability and supply, food security, infrastructure, agriculture, income, and so on. Increased displacement of people. Yeah, this is what the summary of the future risk and impact. So what beyond 2100? Okay, it said irreversibility and abrupt changes. Irreversibility means a lot of things that now getting worse. It won't be restored. Okay, it won't be restored back. For example, you cannot expect we can re-freeze again the ice in the what is it, in the polar, not polar, okay, in the Antarctica, for example. Okay, so the impact will continue for centuries, even if we do everything, because the CO2 that we have been accumulated in our ecosystem is there, unless we take it back. Okay, the warming will continue. Okay, under all of the scenarios except this one. We have to go back into what is the RCP. Also, if we can stabilize the temperature, it doesn't mean we stabilize all. Ocean acidification will continue. Okay, the reason is that the absorption of CO2 to the ocean happens slowly. Okay, it happens slowly, so it doesn't reach the saturation yet at the moment. So the process of absorbing CO2, it takes time, it takes years.